For question 50 from the homework, calculate the enthalpy for the reaction for the following reaction. Iron 3 oxide reacts with carbon monoxide to produce iron and carbon dioxide. Given the following two equations, we know iron reacts with oxygen to produce the iron 3 oxide, and carbon dioxide will break down to give us carbon monoxide and oxygen. So we need to use Hess's law here to take the two equations that we know and the delta H of those two equations that we know to determine the delta H for this reaction that we're curious about. So the first thing I would do is take an assessment of what we have and what we're looking for. So in the reaction I know iron is a starting material. In the reaction I'm looking for, iron is a product. So that means I need to flip this first reaction. And not only that, in the reaction I'm looking for, I want to have 2 irons as a product. In this reaction, I have 4. So that means not only do I need to flip the reaction, but I should divide it by 2. And when you flip the reaction, you're going to change the sign on the delta H. And when you're going to divide, we divide everything, including the delta H as well. So to flip that reaction, I'd be left with iron 3 oxide solid yields 2 iron solid and 1.5 oxygen gas. The new delta H, I need to flip that delta H and divide it by 2. The new delta H would be a positive 824 kilojoules. So I went from 2 iron 3 oxides to 1 because I divided the whole equation by 2. Need to do the same thing for the next reaction. Let's see. I have carbon dioxide as a product, and in this reaction I have carbon dioxide as a starting material. So again, I need to flip this second reaction, and when I take an assessment of what I have and what I'm looking for, I have a reaction that contains 2 carbon dioxide. I'm looking for a reaction that contains 3 carbon dioxide. So I need to multiply the whole reaction by 3/2. So if I flip the reaction and multiply by 3/2, I'm going to have 3 carbon monoxide gas. I'm going to react with 1.5 oxygen gas to produce 3 carbon dioxide gas. So I flip the reaction, I need to change the sign on delta H, and I need to multiply delta H by 3/2 to get my new delta H of minus 848.1 kilojoules. Now I can add those two reactions together, and according to Hess's law, right, whether I do this reaction in one step or many smaller steps, the sum of the delta H's of those individual steps needs to equal the overall process. So I can add these reactions together just like I can add together these delta H values. So by taking a look, when I add the reactions together, the 1/2 oxygen here will cancel out with that oxygen there, and my new reaction will be iron 3 oxide solid reacts with 3 carbon monoxide gas to produce 2 iron solid and 3 carbon dioxide gas. And I can add together the delta H values to see the new delta H for this reaction should be minus 24.1 kilojoules. So again, Hess's law allows us to determine the delta H for this unknown reaction because we know the delta H values for the 2 reactions given. Hess's law is what allows us to add these reactions together and adding together those delta H values. Because again, this is a state function. It only matters where we start and where we end the reaction, not whether I did the reaction in 1 step or 10 smaller steps. All that matters is where did I start in energy and where did I end in energy for this reaction.